Hello there, Mr. Sutton here, bringing you the IM3 1.3 Extra Practice Number 3 solutions on solving systems of equations using elimination. This one's based off of a puzzle. Let me show you the puzzle. So here's our puzzle for this one. The riddle is, what do you get if you drop a grand piano down a mine shaft? Probably nothing good would be my guess. We've got all these systems of equations, and they want us to solve this using multiplication and addition, so basically the elimination method. The idea is we solve these, we figure out which point those correspond to, and we put the letter in whichever box those points are linked to. So let's get going. To solve this systems of equations, first off, it'd be nice if this first equation didn't have this parentheses going on. Now, there's two things you could actually do to get rid of this parentheses. Option number one would be to distribute this. Option number two, though, which is actually kind of interesting here, is if you divide this equation by 2, then that will also get rid of the parentheses, and it'll give you some smaller things to work with. So that's what I ended up doing. Dividing by 2 on the left side just cancels out this 2, so we have x minus y, and on the right side, 4 divided by 2 is 2. All right, now taking a look at my two equations that are both in standard form, I see that we have a positive y and a negative y. If I add the equations together now, those are going to cancel out. So I'm just going to move this second equation down here. I mean, I guess it doesn't really matter which way we move things. And then I'm going to add these two equations together. So negative y and y cancel. X plus 3x is 4x. And then 2 plus 10 is 12. Dividing both sides by 4 to get x alone, we've got x equals 3. Now I'm going to have to plug this back in to find the y value. Now in terms of the best places to plug in, probably the easiest thing would just be to plug it into this x up here in this modified equation. However, I'm kind of out of space over there, and I'm not super picky, so I'm going to plug in this 3 over here instead. But there's lots of places you could put that in. So now we've got 3 times 3 plus y equals 10. So that's 9 plus y. And if I subtract the 9, I get my y value of 1. So I've got the point 3, 1. Now looking at my answer choices down here, 3, 1 is right here. And this letter that corresponded with this problem number was A. So I'm going to put an A right there. For this next system of equations, just like the first one, I don't like these parentheses when I'm trying to solve a system. So I'm going to get rid of those. And again, you could do this by distributing the 3, or you could divide everything in this equation by 3. I, again, went the division route just because, I mean, over here I've got 0, so I'd really like to divide 0 by something. So dividing by 3, on the left side, that cancels out this 3, leaving me with just 2a plus b. And on the right side, of course, 0 divided by 3 is just 0. Now looking at my two equations, if I add these together right away, nothing is going to cancel out. We have a versus 2a and negative 2b versus b. However, if I multiply this second equation by 2, that will give me something that will cancel out with this negative 2b. So I'll end up with 4a and positive 2b. That's why I multiplied by 2 to get that situation right there. And then 2 times 0, well, that's still 0. Now adding these equations over here together, we can cancel out those b's. A plus 4a is going to give us 5a. And then negative 5 plus 0 is still negative 5. Dividing both sides by 5, we end up with a equals negative 1. Let me plug that back in to get the b value. I think this equation right here is probably our best bet. So let's go there. We have 2 times negative 1 plus b equals 0. So that's negative 2 plus b equals 0. And then if I add 2 to the other side, we get b equals 2. Now writing this as an ordered pair, they didn't give us an x and a y, but we can still just go alphabetically if they didn't give us any other kind of details or description. So I'm going to call this negative 1, 2 to match one of my answer choices. And taking a look down here, negative 1, 2, right there. And just in case you were worried, there's not a 2, negative 1 lurking anywhere. So this is the only answer it could possibly be. So let's see, this was I, it looks like, for the letter that was associated. So we'll put an I right there with negative 1, 2. For problem R or 3, depending on how you're thinking about it, trying to solve this system of equations. Now, right away, I notice my equation on the left needs a little bit of work. I want to put this in standard form so that I have all the letters on the left side. I can do that by just subtracting this 2x. 5x minus the 2x gives me 3x. I still have the minus y. I still have the 9 over on the right side. Looking at these two equations now, if I add these together, it doesn't look like anything's going to cancel out right away. But I'm pretty close with this 3x and this other 3x. If I multiply one of these two equations by -1, I'll get a -3x, and that's going to cancel something. So half a dozen of one, 6 of the other on this. I decided to multiply my second equation by -1, so I'm going to bring that down here. This is going to be -3x, and then we also have a -4y, and this -6 is now going to be a +6. Adding these equations together, I end up with x's that are canceling. -y and -4y adds up to -5y, and 9 and 6 gives me 15. Dividing by -5, we have y equals 15 over -5, or -3 if I reduce that. And now I've got something that I can plug back in to find the x value. I'm just going to plug it in over here because I've got lots of room. Probably would be maybe a little faster if I plugged it into this 3x minus y equation, but whatever. We'll just do this. So I have 3x plus 4 times -3 equals -6. So 4 times -3 is a -12. Adding that 12 to the other side, I've got -6 plus 12 giving me 6. And then if 3x is 6, that means x is going to be 6 divided by 3, or 2. So putting that in point form, we've got 2 comma -3. And 2 comma -3, that's over here. And this was problem R, so I'm going to put an R right there. Here we are on problem T, or 4. This system is a little bit messed up right off the bat because we have a whole lot of simplifying and rearranging that we're going to need to do before we can even think about solving these. So let me start with my equation on the left. I'm not liking this 2 parentheses business, so I'm going to go ahead and distribute that. I don't want to divide by 2 like I did on some earlier problems because that would give me like x plus 4 all over 2, which doesn't sound very nice. So just distributing, we've got 2x and minus 6y, and I still have the other side of the equation unchanged. But now we're going to have to move this x to get over with the left side, so we have all our variables on the left side. 2x minus x just gives us 1x minus 6y equals 4. And now that equation is, well, I can at least look at it. It may not be good to go completely, but I can move over to the other one and start rearranging over there first. So over here, it looks like we need to move this 5x and this y over to the left side, and this 8 needs to come over to the right side. So 3x minus the 5x, that's going to be -2x over on the left. If I add this y over to the left side, now I've got a plus 1y there. And if I subtract this 8 over to the right side, well, that's going to be equals -8. All right, now I can at least look at these and see if things are going to cancel when I add them together. If I add these two equations now, it doesn't look like anything's canceling. But I'm pretty close in 2 different directions. If I multiply this second equation here by 6, that would give me a 6y, which would cancel the -6y. Conversely, if I multiplied my first equation by 2, that would give me a 2x to cancel out the -2x. You got to pick one, so I'm going to multiply this first equation by 2. It's a smaller number, so I'm probably less likely to mess things up multiplying by 2 versus 6. So we're going to have 2x, which is why we chose 2. We also have a -12y, and this is all going to equal 2 times 4, so 8. So we've got the -2 and the positive 2x canceling when you add these together. The y plus -12y is -11y. And we weren't intending for this to happen, but it's fine either way. The -8 and the 8 actually do cancel, giving us just a 0 over there. So now dividing by -11, I have y equals 0. Well, that's not so bad. And now if I plug 0 back into y in one of these equations, I'm just going to pick this one because I've actually got room over there. X minus 6 times 0 is what we've got going on there. Now this is cute the way it works out. 6 times 0 is just 0. So that just leaves me with x on the left side and 4 on the right side, simply saying here then that x equals 4. So that's the point 4, comma 0. 4, comma 0 is right here, right down here. So this was problem T. I'm putting a T right there. For this problem, before I start multiplying and adding equations together and all the rest of it, I do want to get rid of this parentheses. Now the trouble here is that if I distribute the 1/3, that's going to give me like 2/3 and 1/3 y, and I'm not really sure I want to mess around with that. So instead, to get rid of this 1/3 parentheses, I'm going to multiply both sides of this first equation by 3. I don't know if that's going to give me anything that cancels with something over here, and I don't really care. I'm just trying to get rid of this fraction. So multiplying that by 3, 3 and 1/3 cancel out. So that just leaves me with 2x plus y on the left side. On the right side, 3 times 1 gives us 3. Now looking at my two equations, if I add these together, we're pretty close, but nothing is going to cancel out right away. Probably the fastest way to cancel something out would be to multiply either of these equations by -1. That would give us a negative y versus a positive y. I'm going to choose the second equation here to multiply by -1. Again, it was kind of a 50-50 chance which equation I was going to choose. It doesn't really matter for the final solution here. So we end up with negative x minus y equals -4. And then if I add these two equations together, my y's are canceling. 2x plus negative x is just x, so that's kind of nice. And 3 plus -4 is -1. So without doing any other work, after adding those, we actually immediately end up with x equals -1. Not bad for a day's work. Let's plug this -1 back in over here, just because I have room over here. So I've got -1 plus y equals 4. If I add that -1 over to the other side, so add 1 to the 4, I end up with y equals 5. So that gives me the point -1, 5. -1, 5 is right over here toward the very beginning. This was problem A, so I'm going to put an A in this -1, 5 spot. Here we are on problem O, or 6, and oh my goodness, look at all these fractions and parentheses and all the craziness here. So before I do anything else, I want to clean up both of these equations a little bit to at least get rid of those parentheses. For the left side, to get rid of the 1/2, I don't feel like distributing that. I just want to get rid of it. So I'm going to multiply this first equation here by 2. 2 times 1/2 is going to cancel out, leaving me with just m minus 3n on the left side, and 2 times 5 is going to give me 10. Over on the right side now, I could distribute this 3, and that wouldn't be completely horrible, but I noticed that -12 is divisible by 3. So I'm going to get really fancy here and just divide this whole equation by 3. 3 divided by 3 cancels that out on the left side, so we've got m plus 4n just all alone, and then -12 divided by 3 is going to be -4. So we've got these two equations here that if I add them together, nothing's going to cancel, but I'm pretty close with these m's. If I can just multiply one of these equations by -1, then I'll have a negative m and a positive m. So let me multiply the second equation by -1. I'm going to bring that down here. So we have negative m right there, and we'll have 4n times -1 is -4n, and then finally -4 times -1 is +4. Adding these two equations together, the m's are going to cancel. -3n and -4n gives me -7n, and conveniently we have 10 plus 4 giving us 14, which is divisible by 7. So 14 divided by this -7 gives us an n value of -2. Now I'm going to plug that back into one of these equations. I'm just going to pick this one because I've got the space over here. So this is going to be m plus 4 times -2 equals -4. That's going to be m minus 8. And then if I add 8 to both sides, -4 plus 8 is going to give me +4 for my m value. Going in alphabetical order to write the point, that'll give me the point 4, -2. So that's going to be right here, and this was problem O, so there's an O right there. And let's go. For this problem, our seventh problem, labeled F, we've got this fraction-y kind of first equation here that I don't really feel like messing with fractions. So what I'm going to do to get rid of those is I'm going to find the least common denominator between the 3 and the 2. The smallest thing those both go into is 6. And I'm just going to multiply this whole first equation by 6. If I do that, since 6 is divisible by both 3 and 2, that's actually going to help me cancel out those fractions and get some nicer things to look at. So multiplying by 6 now, and I'll just put the answer over here. And you'll see why I do that in a sec. I kind of looked ahead to see what I was going to end up with here. 6 times x over 3, 6x over 3 is 2x. 6 times y over 2, that's 6y over 2, is 3y. And then finally, we have 6 times negative 4, giving us negative 24. Now, take a look at the two equations we've got. And this is why I moved it over here right away instead of putting it kind of below there. If you look at this, we actually ended up with these negative 3y's and 3y's that are going to cancel right off the bat. I wasn't planning it that way when I chose 6. I'm just glad it worked out that way. Sometimes you get lucky. So let's add these together. I'm not gonna look a gift horse in the mouth, as they say. So those are going to cancel out, those y's. And then we have an x and a 2x, that's 3x. 6 plus negative 24 is negative 18. Dividing both sides by 3, we end up with x equals negative 6. Now I can plug that back in, and normally I wouldn't plug things into expressions with fractions because, I mean, why go to the trouble? I would think this equation up here at the top would be easier to plug negative 6 into. However, I've got a lot of room over here. So that's kind of what I'm basing my decision on where to plug things in. So I've got negative 6 going in for this x. So that's negative 6 over 3 plus y over 2 equals negative 4. Negative 6 divided by 3 is negative 2, which isn't so bad. I can add the 2 over to the other side. Negative 4 plus 2 is negative 2 on the right side now. And then to get rid of this divided by 2, I'm going to multiply both sides by 2. So we end up with y equals negative 4. And then that's the point, negative 6 comma negative 4. And where is that? That's right here. This was problem F, so I'll put an F right there. This next one, letter M, or problem 8, was kind of a royal pain. This is one where you figure out how much you really love math, because they've given us quite a bit to digest here. We've got some crazy fractions going on in our first equation, and then we have distribution, and we don't even have everything on the same side in the right equation. It's a hot mess. So let's take care of the hot mess before we try anything that's more along the lines of solving a system. This first equation, I want to get rid of my fractions. So just like I did on the last problem, I want to multiply by whatever the least common denominator is, and that will end up canceling out all of these denominators. So between 2 and 5 and 10, to find the LCD with some numbers, I just take the biggest one and keep taking multiples of that until I find something that's divisible by everything. So we'll start with 10. Is 10 also divisible by 2 and 5? It is, actually. So I'm going to multiply this whole equation by 10. And if I do that, I've got 10x over 2, which is 5x. I've got 10y over 5, which is going to be a positive 2y. And I'll have 130 over 10, which divides back down to 13. So the 10s cancel. So that equation, I mean, it's not looking great, but it's a lot better than what we started with. Let me also focus on my second equation to get that prettied up a bit. So I'm going to start by distributing this 3. Got to start somewhere. So we've got 3x minus 3y, and nothing else changes right away. But then I also want to move some things around. Really, I just want to move this x over to the left side so that all my variables are on the left, just like in my first equation. So subtracting x from both sides, 3x minus x is going to be 2x. And we still have this minus 3y, and now negative 10 is the only thing over on the right side. Okay, let me look at these two equations now. If I add these two together that are the last in each column here, nothing is going to cancel out. So I have to decide what I want to cancel and then multiply one or both of these equations by something to make it happen. So choosing between the x's and the y's, My y's have smaller coefficients, so I'm just going to choose to try to eliminate the y's right off the bat. Between 2 and negative 3, if those are both going into 6. So if I could turn this into a positive 6y and this into a negative 6y, those equations would cancel out the y's nicely when I added them together. So let me multiply this equation over here by 3. So that's going to be 15x, and 3 times 2y is 6y. 3 times 13 is 39. And now this other equation then, I want this negative 3y to be a negative 6y to cancel this out. So let me multiply this other equation by 2. That gives me 4x, and now we'll have a negative 6y. That's why we multiplied by 2. And then 2 times negative 10 is negative 20. Adding these equations together finally, the y's cancel. We have 15 and 4 giving me 19x, and 39 plus negative 20 is conveniently just 19. So dividing 19 to both sides, we have x equals 1, which isn't so bad after all that work. I can plug that back in. I'm just going to use this equation here. So we've got 2 times 1 minus 3y equals negative 10. This is just 2 right here. I'm just immediately going to subtract 2 from both sides. So negative 10 minus 2 is negative 12. And then dividing both sides by negative 3 to get my y value, I end up with y equals positive 4. So then my final point is going to be 1 comma positive 4. And it looks like that lines up right here. So that's going to be m going in that spot. We're on to this next problem here, problem n, or 9. Now, if you've been keeping track of how many problems there are in the puzzle, there was only 10 altogether, so that means we only have 2 of these left to do. And if you look at all these blanks down here, there's still a lot of blanks. So clearly some of these blanks are not going to get filled in by the time it comes around for us to actually solve the puzzle, and that's okay. We've got 2 more. Let's do this one now. Just like the last several times, I noticed that my equations aren't quite ready for prime time. I need to clean them up a little bit before I can really think about adding anything together. So for this one on the left side, I'm thinking if I multiply both sides by 5, that would cancel out that 1/5 nicely, so I don't have to distribute it. So left side cancels out with the 1/5. That's just going to be x plus 2y. And then negative 2 times 5 gives me negative 10 for the other side. Now over here, I've got a bunch of fractions. I want to multiply by my least common denominator to get rid of those denominators. Between 4, 2, and 2, 4 is the smallest thing that all of those denominators divide into. So I'll multiply this whole equation by 4. I end up with 4x over 4. 4's just cancel. That just gives me x. Next, we have negative 12y over 2. That's negative 6y if I reduce that. And here we'll have 60 over 2, which is 30. Now, if I add these equations together, I'm pretty close, but nothing is quite canceling yet. However, if I multiply one of these by a negative 1, I'll have an x and a negative x, and then something's going to cancel out. So let me go ahead and actually just multiply this second equation by negative 1. Doesn't really matter which way we go on this. So we have negative x, and then negative 6y is positive 6y, and then we have negative 30. Adding these together, x's are canceling. 2y plus 6y is 8y, and negative 10 plus negative 30 is negative 40. Dividing both sides by 8, we have y equals negative 5. And now it's time to plug that back in to figure out the x value. This equation here actually will work out pretty well for plugging in y. So I have x minus 6 times negative 5. Negative 6 times negative 5 is positive 30. And if I subtract 30 from both sides, I get an x value of 0. Well, that's kind of cute. So we end up with 0, comma, negative 5. And where is that? So looking down here, that's right in this spot right here. This was problem n, so we'll put an n right there. And that spells out the word minor, but I'm not really sure until I do that last problem maybe what this whole puzzle is saying, or even if that's an entire word and there's not more to go. So let me keep going. So here we are, final boss battle, the last question, the last letter to put in our puzzle. And it lives up to expectations. It is definitely not something to be trifled with at first glance. However, we have been dealing with these fractions for a while in this puzzle, so hopefully by now we're starting to get the hang of this whole multiply by the LCD trick that gets rid of fractions so nicely. Taking a look at my left equation here, we want to find the least common denominator for 6, 4, and 2. So I'm just going to start with 6 and start taking multiples of that until I find something that's divisible by these other numbers. Now, is 6 itself divisible by 4 and 2? It is not divisible by 4. The next multiple of 6 is 12. 12 is divisible by 4 and 2. So 12 is what I want to multiply that first equation by. So 12 times a over 6, 12a over 6, gives me 2a. And then we'll end up with a 12b over 4. We can reduce that to 3b, and that's positive. And then finally, 5 times 12 is 60. 60 divided by 2 is going to give me 30. Next, over on the right side, cleaning this up, we have an LCD for 3 and 2. The LCD for that is going to be 6. That's the smallest thing 3 and 2 both go into. So I'm going to multiply this by 6. Now, I looked ahead a little bit to see what I was going to get after that happened, and I'm going to end up with a negative 6b over 2, which is negative 3b. That would cancel this 3b over here. So I'm actually going to multiply by 6 and put my answer down below here because I already know, sort of by looking ahead, that I'm going to end up with something that's going to cancel with this equation. So multiplying by 6, we end up with 6 times 2a is 12a divided by 3. That's 4a. And we just said that 6 times negative b over 2 gives us negative 3b, which is what we were looking for anyway. And then finally, 6 times negative 2 gives us negative 12. So adding these two equations together, right away those 3b's are canceling. 2a and 4a adds up to 6a, and then 30 plus negative 12 gives me 18. Dividing by 6, I end up with a equals 3. And now I'm going to plug that back in somewhere to come up with a b value. Now, I normally would probably plug this into one of the equations that does not have fractions in it, just because I feel like I'm going to handle that better. But I've got lots of room over here, so I'm going to take the extra challenge of plugging 3 into a over here. Even though I know that if it were up to me to plug in any equation I wanted, I would probably choose one of these that doesn't have fractions. So here we go. Let's give it the old college try. So we've got 2 times 3, that's 6. 6 divided by 3 is 2. So that's actually not horrible. And then we'll keep going now. If I subtract this 2 from both sides, negative 2 minus 2 is negative 4. And if I want to get rid of this negative 2 that I'm dividing by, I can just multiply both sides by negative 2. So that gives me a positive 8 over on the right side. Putting these in alphabetical order to get a point, we end up with 3 comma 8. 3 comma 8 is right here. This was problem L, whatever that means, so we'll put an L right there. And that was our last problem, so we are finally ready to solve this puzzle. To solve the puzzle, let me just show what the riddle was again. What do you get if you drop a grand piano down a mine shaft? And this is already nicely spaced out, so we know what is part of what word here. So we have A, flat, minor. Okay, well that's a cute little answer there. So A flat, that's a note, so you would play that on a piano, and minor notes are also on pianos. But of course, if you actually drop a piano down a mine shaft and there's a minor, different spelling though, at the bottom, it's not going to end well for that person. All right, so that's it for this puzzle. Mr. Sutton signing off.